All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanagh, is here with an old friend of mine and a new friend. We're going to talk about one of the hottest topics in the world of large language models. We're going to talk about RAG, Retrieval Augmented Generation, and also Graph RAG, which is a particular kind of RAG that, according to my research, is doing really good things to ground these large language models to get them to behave like good students, like good interns, and that's what we want from them. We don't want hallucinations. We don't want them coming up with wacky ideas. We want them doing what we ask them to do, which is to focus on our enterprise data and our questions and give us good answers that are relevant for us and for our customers, our prospects, etc. So we've got Philip Rathle of Neo4j. He is the CEO over there these days. I've known Philip for, gosh, about 20 years, I think. And we have Jon,
CTO.
I'm sorry, CTO of Neo4j, and Jon Brewton, who is with a company called data². So we'll talk about what this stuff is, why it matters, and just to give some quick context, RAG models are a really useful way to guide and shepherd the output of large language models. So with a RAG model, typically you will have a vector database into which you post your embeddings, which is basically like you're training your vector database. You're giving it lots of embeddings, they call them, which are like anchors of truth. It is, and it's part of the workflow when you leverage a large language model to give you some really good control and guardrails around the outputs of the large language models because they are large and they are very unwieldy. So we'll talk about how graph plays into that as well. So Philip, CTO, sorry to your CEO out there, CTO of Neo4j, you're the graph company. You guys have been doing graph for a long, long time. Tell us how graph plays into RAG.
Yeah, great to be here again, Eric, and hello to the guests. Yeah, it's graphs are have just been horizontally becoming more and more useful for more and more kinds of uses over time. So it's in a way only natural that they would show up in AI in some way, and the way in which they've shown up is I think introduced really nicely. Retrieval-augmented generation is this technique which probably everyone on the call has done, if not at least heard of, which is reflects the fact that an LLM is this probabilistic model that will basically, do advanced word completion or, however you want to think about it, and can do really well with create activities where, let's say, creativity is a feature, not a bug,
Hmm.
and where you've got some level of latency between the training period and the time you're asking the question is acceptable, and where there's the question you have is about it relates to the corpus of data that's maybe more broadly available to the world as opposed to your specific one inside of your company that no one else should be able to see. And vector-based RAG is based on this technique called word embeddings, which gives you a way to do math on effectively um, pieces of language to see what is similar and the conceptual distance between different words. That's very useful. That raises the bar. It makes it possible to do more with an LLM than you otherwise could with the LLM by itself. But you're still in this world of approximation, and you're still in this
Mhm.
black box world of you can visualize a vector, and guess what? It's like 1,000 plus numbers, and you really can't make heads or tails of it as a human. And all a machine can really do with it is just compare distances. So it's a powerful tool, but you very quickly run into the limitations. And where graphs come in is to give, I think of it as adding a left brain to a bunch of technologies that otherwise behave very much like a right brain. Right brain, or Kahneman's fast thinking system is spontaneous and creative and gives you fast answers. And those answers are usually right, but sometimes they're way off the rails, and I have no
Right.
idea why, right? And so that's why we all have a left hemisphere is to, or slow thinking system is to keep that in check, to rationalize, to be able to explain our ideas to other people and to ourselves. And graphs give you a way of representing the world model for whatever domain it is you're working with inside of your Gen AI application. and then being able to refer to it to either ask exact questions and come up with, exact not only answers but traceability and explainability, or to
Hmm.
be able to, as Jon will point out, they've innovated another really nice way of using graphs where you can pull a large portion of the world model, feed it to the LLM, and then get a creative sparring partner. So there are a bunch of ways in which
Hmm.
graphs are being used throughout industry. We can talk about some other companies that are doing this as well. Klarna's a pretty you know pretty big and well respected in terms of their Gen AI applications. Turns out the not so closely held secret, but maybe less known, is that at the center of their Gen AI application is a Neo4j based knowledge graph,
Hmm.
for making these questions uh, better. So not only more accurate, but more, bringing in additional information that you just don't have in the model and might not have in the vector. Um, Number two, making it easier to understand the data that you have, because a graph is, shaped in the same way that people think about data, the way the brain is shaped and processes data, and the way a business person will whiteboard their logical or conceptual model on a whiteboard. And then last but not least, explainable and with some governance hooks. So that's GraphRag in a nutshell.
Yeah, and graphs, I mean, of course, graphs have been made famous by LinkedIn, by Facebook, for example, because graphs are very good at helping you understand relationships between entities, right? You have nodes and edges. The nodes are the entities, the edges are the characteristics of those entities. So I can see how graph in a workflow for a RAG model would be very useful. Maybe I'll throw it over to Jon to add some more context on this from data squared. It's giving you this deeper, richer context in which the large language model can then operate, and that's what fine tunes the answers you get from it, right?
Yeah, that's right. So Jon Brewton, CEO of data² at a super high level. Just to introduce our company, we're partners, go-to-market partners, and thought partners with Neo4j, and we are doing some stuff that's slightly differentiated and interesting, as Philip already alluded to, through sort of graph rag operations. We built a platform for next gen tools and high reliability environments like defense, intel,
Mm.
engineering, and finance. Our company is a whole bunch of military vets. We all were Air Force, Marine Corps, Navy SEALs, Army intelligence, and we all worked in the energy industry. So I had
Hmm.
17, 18 years at Chevron, engineer by background. And, we've been trying to solve problems forever. And, I think knowledge graphs are really important because I think traditional systems, when you try to do traditional intelligence analytics or just analysis, they see things in disconnected rows and columns. And whenever you use a graph, you get to reveal sort of a going from 2D to 3D landscape where what we do is slightly differentiated in that we set up workflows so that we can actually see every connection, how they're discovered, how they're connected to each other, the context associated to how any individual piece of that data environment is connected to any other piece of that data environment. And our goal was to create sort of this unified, enriched data environment where we could apply graph analytics and really start to get powerful, trustworthy, and explainable outcomes. I mean, we're operating in a high reliability environment, and that's a necessity. But graphs themselves enable our ability to really see, as you talked about, the connective tissue between the entities within the structure and the evidence or the information in the structure. And knowledge graphs really unify those relationships and allow you to deploy tools that can work within that orchestrated layer of context. You can enable
Hmm.
agents to work in that space. You can actually start to deploy really smart tools to, as Philip alluded to earlier, sub-segment these environments in really smart ways so that you can control the contextual relevancy of the information
Hmm.
to its constituent parts that are relative to the problem that you're trying to solve at that point in time. And so
Right.
graphs are an incredible unlock, just from a data model perspective, in your ability to sort of move from 2D or flatland into sort of this rich three-dimensional structure with real tangible connective tissue between each one of the pieces of your data environment. So that's
Yeah.
why we believe they're just fundamental and important to scaled AI implementation over time.
Right. Well, and of course, AI is only as good as the data that it is fed or that it is trained on. And these large language models, they are very unwieldy. They're huge. I mean, you've got billions of parameters in these things. And, I keep going back to Sam Altman's curious comment about a year ago where he said, oh, the era of large language models is over. And we're like, what are you talking about? Aren't you the guy who just like unleashed one? Like, what are you talking about? I think that what he meant was that I think he saw the handwriting on the wall and he knew, yeah, they're pretty unwieldy. We're going to have to come up with ways to deal with that. But I'll throw this over to first you, John, and then to Philip. What gets me really excited about this stuff, there are lots of things, but one is that I've spent all these years in the structured data world, data warehousing, business intelligence, all numbers, tables, rows, for example, columns. It's a fairly two-dimensional view of the world. Well, none of that has any meaning without the context, which is in your unstructured data. But hitherto, we didn't really have much of in the way of tools to leverage all that unstructured data. It was just kind of all this unwieldy stuff out there that we, had to sort of manually go through to try to put some pieces together in our head. Now we can. Now we can use the large language models, especially infused with a graph model to really wrap all that context around the structured data. What do you think, John?
Yeah, no, I think it's fundamental whenever we talk about, especially high efficacy rate returns. When we're looking at the performance of traditional RAG models, I think your last podcast, or at least one I listened to very recently with Michael Kravik from Blue Yeti, you were talking
Sure.
about, RAG. It's kind of what everybody's working on right now. The best you can get up to is 90% and somewhere in that space. And that's true for like single point of inference, like query. Whenever you're looking at something, you can really sort of try to control that environment. But as you start to scale or try to scale your ability to apply that to a broader base of information, like it really starts to affect the accuracy. And I think that's because vector-based RAG relies on text and keyword similarity for information retrieval, which can really start to miss and overlook what are critical nuances and the
Mm,
contextual similarities and just the actual contextual relevancy of one piece of information within that structure to another. And that approach doesn't really allow for sort of scaled, repeatable application of high efficacy workflows. And this is where, from our perspective, like graphs are the absolute critical unlock for this. And so, yeah, there's traditional RAG systems. They're great. They have their place. I think whenever you're looking at high reliability industry, anything like defense engineering, where the cost of failure is exceptionally high, I don't think you can actually build a scalable generative AI solution that you could deploy in a trusted capacity without a graph data model being the
right.
underlying sort of structure for how you use that system.
Right. That's right. And as I throw this over to Philip, you may have heard me say this, John, if you listen to that show with Michael Kravik. I can't remember if I mentioned it or not, but you say efficacy of 90%. Well, that sounds good, but ask yourself this question: which part of your business can be wrong 10% of the time? Fulfillment,
Mm-hmm.
accounting, operations? No, like that stuff has to be right. And so what we're dealing with here is the deterministic worldview from structured data, from data warehousing, for example, databases. I mean, you load data into a database. When you pull that data out, it is exactly as it was when you load it in. And if it's not, you better get a new database because something broke, right? So that is 100% deterministic. You're going to get what you put in. Now, garbage in, garbage out, obviously, is a factor we all have to deal with. But still, like as you suggest, if you need an accuracy rate over 90%, you have to have some other component. In my opinion, it is this graph. It's the graph that is going to get you probably closer to 95, 96%. And then, everyone makes mistakes. We'll never get to 100%, at least I don't think anytime in the near future. And humans are not 100% correct. But boy, if you can start getting over 95, 96, 97%, Philip Rathle, I'll throw it over to you. That's where you're really getting somewhere and you can trust and you can kind of breathe easy. What do you think?
Yeah, so it's natural when a new technology emerges to swing the pendulum all the way over to let's use it for everything. And then in that process, you learn what it's not able to do, and then you quickly, dial back and to some point of what's the right equilibrium. And here, we've dialed way over into let's use a probabilistic engine that is GPU
Right.
dependent and very latent and very computationally expensive, though I'll grant that the price is dropping like a rock, but still relative to the compute that it takes to run a sub-millisecond query in a database and get an exact answer, um, is still very expensive. And we're using it to answer every question. And so, like you said, well, as it turns out, some questions actually have exact answers. And so let's remember that. And it's possible to get those exact answers from database technologies. Now, where graph database technologies excel and is number one, being able to pull data from anywhere, assemble it. You were talking about schema, like what's really powerful with a schema flexible implementation of a graph database is that you can just take data in, and your schema becomes an emergent property of the data. Like I don't have to figure out what my data looks like before I load it into the database. And early in
Right.
my career, when we met, Eric, I was worked as a data modeler and PM for a data modeling tool. And you would, it would be normal to spend 3 months haggling through like conceptual to logical to physical and normalize, denormalize. By the time you've done that these days, like the business has moved on. and then
Right.
and then it's like another month. And God forbid there's data in the database and in the model. And then you have to evolve it. Then, oh my God, um, and so having that flexibility to just take whatever data you want, and then have the relationships be a first class um, element in your model so that you can then bring this additional richness of the relationships into the data and use that to get better answers. And if I flip the question and look at it from the top down, as a CIO, I want to be able to use data from across my enterprise and stitch it together.
Hmm.
Enterprises are graphs, as it turns out. They're structured in silos. And so you can use the graph to connect the different parts of your business through an enterprise knowledge graph to get an AI that understands your entire business.
Yeah. Yeah, this is really interesting stuff, and I like the way you put that. We'll pick this up after the break. That enterprise, like a graph, is probably the best way to represent any complex structure, especially in enterprise, because you have lots of people; those are nodes. You have lots of systems; those are nodes. These are kind of different strata. But to be able to really understand and wrap your head around how it all fits together, that's a graph when you get right down to brass tacks. So, folks, don't touch that down. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, talking all about Graph RAG. RAG, of course, is Retrieval Augmented Generation, something that came out of Meta as a way to ground large language models and really give them some anchors of truth, is how they've been described to me. But as Philip Rathle of Neo4j, their CTO, mentioned earlier in this call, a lot of RAG models relied just on those vector databases that I talked about. And vector databases are just math. It's probabilistic, because what these engines are doing is they're taking text and they're converting it to vectors, which are mathematical formulae, and those vectors can then be number crunched, because it's hard to number crunch letters. The letters don't number crunch. So that's why they convert letters to numbers and then back. And tokens are really like a token is like half a word, is how I've heard it described to me. So these token and what these engines are still doing, which is kind of hard to believe, is just predicting the next token based upon the pattern that they've seen your prompt and their training, which is amazing, because you see some of the answers you get and they are fantastic, primarily for topics that are widely published about, because large language models really are consensus engines. When you get right down to it, that's what they're doing, is they're showing you the average of what they've seen based upon their training and your prompt. But that's still, it's not fully rich, it's not fully reflective of the real world around us. Whereas graph adds this another really powerful layer, a knowledge graph in particular, that really raises the stakes and gets you into that 95, 96% range or even higher. And we've got Jon Brewton here from data². You've got some really good results. Tell us what kind of efficacy you get and how it's all coming together.
Yeah. Look, I think it's really important just sort of structurally, like graphs are a big part of how you can get better results. Having structured data stored in relational databases is still really important, and having hybrid RAG applications when you're trying to retrieve some of that information is really important. But I think it's more about process. Using a graph allows you to encode domain knowledge and verifiable sort of logic rules. you can deploy
Oh,
agents
wow.
against and within. And this is really critical in regulated domains like intelligence, engineering, finance, healthcare. The mathematical foundations for like just ensuring decisions are traceable and audible are achievable. In some of our customer implementations, we've been able to achieve 99% accuracy and zero hallucination rates when deploying our workflows. That's comparing sort of traditional RAG anywhere from that 60 to 80%. But we do it really sort of using the graph structure for improved retrieval. So we're unlike traditional retrieval methods that rely solely on text similarity and therefore kind of miss some of those critical pieces of information. Knowledge graphs leverage these relationships amongst these data points to surface information that might not share the similar textual content, but they're highly relevant and contextually important to each other. And it's like the connective tissue between these points. That enhances your ability to define the context and the relationships that are explicit within the structure of that data environment. And that really helps you sort of guide and control how these pieces fit together, what you're passing to these large language models, what they're seeing, what they're using, and what they're returning. And as long
Mhm.
as you have a clear and auditable understanding of that data environment that you're subsegmenting from a broader data environment for that question, and you can pass that in a constrained way to a model, you can actually test the outcomes of the returns
Hmm.
against what you know about your database and what the model is returning. You can eliminate hallucinations as a byproduct of that, and you can actually drive the efficacy rates up on return significantly to plus 96%. And so
Hmm.
that's been our goal the whole time, is to try to get to a point where we can get some customer implementations that really show this, and we're lucky enough to have that right now. And graphs are inherently a very, very large and critical unlock to sort of any scaled application of generative AI solutions in a business.
Yeah, and I'll throw this one back over to you, John, and then maybe get you to comment on it, Philip. I want to understand the workflow, and I think you just dropped some hints there. So, of course, these large language models, whether you are using one that is a public-facing one, I think you are going to see some companies deploy their own small language models on-prem. I do know some companies that are doing this. I think it's a very
Yeah.
interesting decision to take. Because you then certainly own it, you control it, it's in your environment, but you're not really benefiting from the advances that are coming to the larger models like ChatGPT, which is really moving faster, I think, than any of the others that I've at least played with here in the States. But the point is, you with the RAG, with the graph RAG, you are adjusting what goes into the large language model, correct? Or are you also hitting it on the way back, right? Because you have this workflow where you can do X
Yeah.
number of things before you hit the LLM and X number of things after you've hit the LLM. With your solutions, are you mostly on the front end or are you also on the back end of that?
Both. So I'd say this actually came up in the last podcast as well, when you were talking about Victara and their CEO. He's used to be
Right,
the co-founder of Cloudera. You talked about RAG focus and sort of looking at the inputs and the outputs to give quality assessment checks on
right.
what you're getting out of the system, and that being a clever approach. I think whenever we look at these systems, we try to control all aspects of what we understand about the data environment and the problem that we're trying to solve. And that's really important because you're moving from a structured data environment, unstructured data environment, semi-structured. You're combining all this information together, which is another really important piece of this graph benefit puzzle. But that allows you to understand the relationships between every one of these points, so that when you do ask a question, you're actually seeding the contextual relevancy of the data that you're
Right.
operating within to understand how to subsegment that environment. And we have a lot of patents pending around how we do this, and like ultimately what we're trying to create from an explainability perspective. But what that allows you to do is control the inputs that you're passing. You understand fully what the contextual relevancy is of that data, regardless of how you subsegment it. You understand how it's connected to what it's connected to and why. And as a byproduct of that, you can actually say, like, here is the contextually relevant pieces of the puzzle for the question that I'm asking, Here's what you
Right.
need to understand about a large language model. Use your training corpus to inform how you answer this question, but not what you answer it with. We can then take those outputs and grade them against our understanding of that environment and what that means for not only whether or not there's any hallucinated content in there that we can actually get rid of before the customers see it, but more importantly, is there any sort of value that's missing within the way those answers are constructed from an intelligence perspective, working with three-letter agencies in the federal government space? This is really, really important. It's not only whether that answer is correct, it's that the value of that answer that was provided to the analyst is in fact representative of the value that we'd assign to those pieces of information in the data model. And so we have a couple of workflows that we're executing, which allow us to really sort of understand what we're subsegmenting, pass what we're passing, how that's being viewed, what's being returned, grade those returns for a factual basis, and then the value contribution to the answers that we'd like to see with subject matter subject matter expertise interface in that workflow.
Yeah, that's amazing. And this is the new recipe for success, it seems to me. Philip, I'll throw it over to you. And I think that you're going to more and more see organizations designing these workflows that Jon is talking about for how they absorb these technologies and use them. And it's pretty important stuff, getting that workflow right. And of course, understanding the costs. I mean, I love Vectara's approach where they have a separate model that comes in at the end and just kind of validates, make sure, okay, does this look good? This is the input, this is the output. Okay, it's a quality assurance checkpoint basically in the process. But there is a cost side of this, and I don't think we fully understand yet what the long-term costs are going to be because it's been so heavily subsidized. So, well, I mean, that's kind of another shoe left to drop. But from your perspective, Philip, this is the new reality, right? And I've kind of suggested on previous shows that many software vendors are going to have to figure out where do we fit in this new world because I think it's going to require the kind of refactoring that was necessary to get into the Kubernetes world, which was very significant and very, very, very much game changing. But what do you think, Philip?
Yeah. So I guess first of all, in terms of the trend, obviously it's hard not to agree. And I was just seeing a stat this morning from Gartner where they predict that 80% of applications in 2 years will have some Gen AI component.
Jeez.
There are a bunch of different drivers for that, right? But we're all seeing it. There's no doubt. The other thing, and Jon, you illustrated this, I think, really beautifully, is AI does not equal to LLM, as much as if I look at, some of the regulation that's been put in place or attempted to um, has regulated LLMs and AI as if those two things were synonymous. Like one
Right.
model
That's
is
right.
AI, but actually what AI
Yeah.
is, it's a composite system made up of oftentimes a single query can invoke many different models pre and post, as we just talked about. And then
Right.
you've got calls out to something like a vector similarity and calls out to a graph, and who knows what else. So these AI systems are complex and composite, and success will lie in having the right tools, understanding when to use them, how to stitch them together. If I look at um, AI as the Swiss Army knife of or as depending on the Swiss Army knife of different tools, graphs themselves as a tool in that toolbox are themselves a Swiss Army knife. And this is one of the beauties, and I think your head can explode a little bit around this too, but it's why I'm still doing this after more than a decade, is number one, um, there are forms of unsupervised graph machine learning known as graph algorithms. And effectively, what they do is they'll look at the connections in a system. So picture a social network or a computer network, or let's say I'm trying to understand the spread of information or potential vulnerability in a computer network. You could just see how it's connected. You can see how data is flowing through it, and then you can run one of these graph algorithms or multiple and look at, all right, what are the devices that are only connected to that are the only connection between two clusters of activity? What are the things at the center of a cluster of activity? Like this is a big deal when you're trying to find bad guys as well. Like who's the
Yeah.
person connecting these two cliques? Um, so there's graph machine learning. It's like what can the system and its behavior tell us about the individual things, and what can the individual things tell us about the overall system? You've also got just pattern matching. You can say, here's a known pattern of money laundering. Now just go search a billion payment transactions and look for that pattern and bring back all of
Right.
them. And bang, you can't
Right.
hide. And yet, another example is supply chain risk comes up a lot. Asset ownership risk, ultimate beneficial owner, these kinds of things you often see in times in different companies. And a supply chain risk, like whether I want to reroute my boat, from the Suez Canal around the African Cape, depending on, whether the ship's still stuck and so on. It's very high stakes. I don't want a 90% accurate result because the cost of a wrong result is too high. Now, getting to the right answer, let's say I have a product that includes many components from different suppliers. Whether I can wait for that ship or not depends on, might depend on chasing your supply chain 20 levels down your tree and then doing
Right.
some math.
Right.
An LM's never going to do that, or at least I don't see a path
Yeah.
forward in the near future. And so if you want to build something like this today, you can run that part of the calculation, just the supply chain risk. It's a multi-level thing, involves math. The graph can handle it like this. And then you flip it around and let the LLM take care of the rest of the decision.
Right. Wow. And you said a couple really poignant things right there. And John, I'll throw this over to you. We got about 2 minutes left in this segment, so we'll pick it up
Sure.
deeper in the next segment. But AI agents are not the same as LLMs, right? I mean, AI
No.
agents can use LLMs, and I think this is like the hottest space. But I'm very concerned and at the moment skeptical about how well these things are going to work because of guardrails and the need for guardrails, because of how unwieldy these things are, and how they can change their minds very, very quickly and do all kinds of different things. So we'll kind of pick up the AI agent thing maybe in the next segment, but just quickly comment on how there are lots of old AI models. AI is not new. We've had it for decades, quite frankly, but we just never really had the compute power, never had the data necessary, I think. But to your point, there are going to be lots of different models out there that need to be managed differently. 1 minute, go ahead.
Yeah, I think being able to connect to legacy architecture infrastructure, the existing models is really, really important. And that's playing a game to harmonize sort of data types across data environments and understanding how you can pull information and what's relevant and important to the information pools that exist sort of in legacy systems. But whenever you're doing any of that stuff, if you're doing it through sort of a traditional relational database structure and you're engaging LLMs in sort of a RAG concept basis, you're still playing a probability game at the end of the day, trying to
Right.
minimize model entropy and understanding its responses are working from a foundation that isn't inherently and persistently structured with connective tissue that's defined and verifiable sort of in nature. You're broadly playing a game of matching at the end of the day, trying to increase your token probability and reduce the overall entropy and the returns that you're sort of trying to create. And the Wall
Right.
Street Journal did a great article on this relatively recently, and they talked about traditional methods that you could use. And while there are a lot of things, whether that's sort of detailed prompting, chain of thought reasoning, verification steps that we've talked about,
Right.
you definitely need to constrain the statistical prediction framework if you want to get high reliability answers.
Yeah, folks, we'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, a fascinating conversation with Philip Rathle. He's the CTO for Neo4j. That's NEO number 4, letter J, Neo4j. And Jon Brewton of data². I love that name. AI agents, I view these as sort of semi-autonomous mini apps that have layers of decision making around the nut, if you will. So there are layers that are determining, should I do something now or should I not do something? Once it's asked to do something, it's like, okay, now how do I do this thing? And it's not like your traditional if then statement. It's much more complex than that because it can take into consideration a whole variety of factors and data. And for example, just the other day, I was talking with a gentleman who runs Red Panda, which is a streaming service. It's like Kafka, but written in C sharp, so it's a lot more efficient. And he was talking about how these streams are going to be the perfect information sources for AI agents because they are very much timely. There's not a lot latency. You're not trying to wait to hit some database. It's just data that's flowing past you. And he says that's going to be really crucial for AI agents, for agentic AI, as it's called, to be successful because they need the right context at the right time when they're asked to do something. But Jon, if you would just give us your definition of AI agents. Am I on target or am I off? Or let us know what you think.
Yeah, no, I think you're right. And I know Philip will have some really good thoughts on this as they're working on some interesting stuff. I think agents inherently do a couple of things or a few things. Like you design them to observe certain things. Philip talked earlier about being able to do pattern matching in real time. That's a very discrete thing, right? We have a repository of understanding, we have sensor data, we have user inputs, we have differentiated data feeds, but we have a baseline that we're trying to check those things against. We can orient those agents around those patterns in that context. That allows us to set up decision engines within an agentic sort of AI framework where we're looking at goal determination or at least planning and execution of a workflow or risk determination of something in real time. And that allows us to define sort of an act phase of what we want these agents to do on our behalf. So I think
Hmm.
it starts with observation and understanding of how you orient within the system, what you're chasing within that structure, and then what you want them to do once you get the requisite pieces of that information to make decisions. Um, I think at the end of the day, that's what we want agents to do. I was struck in one of the previous conversations that you had on your podcast where you talked about sort of how do you create the better outcomes, and one of the conversation points from Michael was around agents working in sort of very specific or discrete task areas. And I think that's really important just within the structure of anything. I don't think all information streaming needs to fit into a graph, but the information that's representative of the problem that you'd want to solve at a detailed sort of frequency, absolutely somewhat necessary. And I think being able to focus your data environment around a problem that you're trying to solve allows you to design and deploy agents in really meaningful and targeted ways within the structure of those workflows. So you can define the problem, define the workflow associated to how you would solve that problem, define the operators within that workflow, chop them up discretely and say, you have this piece, you have this piece, you have this piece, and install checks along the way to make sure that you can verify that information. In our mind, that's the right way to sort of approach deploying these things. It's sort of
Hmm.
the old blue sky, boil the ocean problem solving. Do we need all of the data in the company in one place? Well, maybe not, but you might need discrete elements of that data associated to a given problem that you're trying to solve in a given repository so you can
Right.
understand what you're doing there.
Right. Well, and Philip, I'll throw it over to you. I mean, what I've heard time and again now is that you do want your agents to be very focused on a certain thing, grabbing data, observing something, taking a decision, for example, and have an orchestrator, for example, on top of them. So one that decide, okay, you do this, you do that, you do this, go do your stuff, and when you come back, I'll then make my next decision. That precision seems to be pretty important, right, Philip?
Yeah, so I like the functional sort of outside in definition of agent, which is essentially, based on the term agency, right, which says it all, is it's a it's a system to which I am imparting agency and letting it do its thing and trusting it for whatever that level of trust is. And the reason that I think now we're all saying, oh, we want to do that for like more fine-grained kinds of things is we know that, it's just like Pandora's box is going to open up and, I'm going to make myself liable to potentially a lot of bad things happening if I open up the aperture too much. So you can slide your granularity either up or down, or let's say fine-grained or coarse-grained with agents. And yeah, I think more finer-grained or agents right now certainly seems more in line with where the technology is.
Mm.
If I look at the concept of agency more broadly, you ask yourself, all right, what's the role of the human in this? And I believe you have one of three choices as a builder. You can either say, I'm going to let this agent run unchecked completely. It will make its own decision. It will act on behalf of the company for the customer if it's a customer facing type agent. Um, And then, I don't even really care about how it got to the decision. A black box is fine. And that might be okay for certain kinds of things where the stakes are low. And, look, like I can't think of either a voice menu through, a dial-in voice or like a chat app on a traditional, like rewind a year, any chat app, they're all so bad that I'm always escalating to an agent. So like I if if I'm building one of those, the stakes are fairly low so long as it doesn't commit commercially on behalf of the company, and I can make sure that doesn't happen, which is almost like a security red teaming concern. Then I'm okay. Then you have decisions where the you need a human in the loop because the stakes are very high. My accuracy isn't good enough. And by stakes, I mean brand and reputational impact, high dollar value, um, regulation, audit, health and human safety. And this is the co-pilot kind of use where the human makes the decision and then the AI helps. And I guess in this case, by my earlier definition, that's not an agent, it's a co-pilot. The human is the agent,
Mhm.
it's making the decision. But
Right.
then the last one is the I'm going to give this thing agency. So the agent makes the decision, but I should be able to cherry pick any transaction and a human should at any given time be able to go and understand how that decision got made. And that is actually really important for many kinds of use cases because at the end of the day, as much as it's nice to have computers around running and making decisions, that's very efficient. Um, there is going to be a throat to choke inside the organization, whether it's me or someone else on my team, if the agent misbehaves. So, in order to delegate more agency to higher stakes kind of use case agents, you need explainability and you need determinism, and you
Mhm.
need a graph, I would argue.
Hmm. That's an excellent point, and
Absolutely.
I mean, you're hitting several nails on the head here. One of which is being able to get explainability. And the irony, of course, of open AI is that it's now closed AI, so you're going to have a hard time getting too much explainability out of that. But you saw very quickly these big engines recognize the need for citation. I mean, that happened like, I mean, people started complaining about it, and a few weeks later, you started seeing citation in
Mhm.
these things like, okay, I got this here, I got that there. That's what you want. I mean, click
Yeah,
answers
which is
is
partial explainability. Like as I see it, a citation is
right.
Yeah.
okay. I, these three 500-page documents were used in making the decision. What the logic was is anybody's guess, right?
That's funny.
Uh,
Go ahead, real
we
quick, John. Go ahead.
we actually have a fairly well-defined workflow. Whenever we talk about explainability, we talk about it so that we can cite and source every piece of the data environment down to the data record level, because we
Wow.
can understand the correct connective tissue to sort of ground the systems. We understand sort of how it's functioning within that environment, the tangible nature of the connective tissue from one thing to the other. We're able to cite all the way down to the individual data record level. We use this
Wow.
line, this piece, this number from this cell, from this piece of information to inform how we answered this portion of your answer. That explainability piece, and I hate to like go back to your previous podcast, but you talked about dotting your I's and crossing your T's associated to highly regulated environments with Michael.
Right.
Like that is an absolute imperative to any scaled application of generative AI functions or solutions
Right.
in those environments. Like you have to be
Right.
able to do that. You can't sort of infer trust. You have to be able to define it, to Philip's point. So
Right.
important.
And and I'll throw this out there. We got the podcast bonus segment coming up next, but this is very, very important for senior executives, especially in the risk space, the compliance space, to understand and to appreciate. It's very true that some of this stuff is probabilistic. You got to be careful with some of it, but I'm here to tell you, the black hats are using this stuff, and if the white hats don't start
Mhm.
using it, you're going to be, it's like the drone warfare that we're seeing in eastern Ukraine right now. Drones revolutionized warfare because all of a sudden these big tanks are now lumbering targets when they were the major threat before. And drones are cheap as can be. Drones are an interesting metaphor to these AI agents. But we'll be right back. You're listening to DM Radio. All right, folks, time for the podcast bonus segment here on a fascinating show with Philip Rathle of Neo4j and Jon Brewton of data². And we were just talking about drones and how they have revolutionized all kinds of industries. I mean, not just warfare, insurance, um, uh, scanning for things, land management, all kinds of stuff. Drones are incredibly powerful, and so are these agents. And they're small. That's why I think that's it's an interesting metaphor here. They're small. They have agency. They can do all kinds of stuff that previously needed bigger things to do. But Philip, tell us about your metaphor for graph.
Yeah, I was meeting with a customer lately in government, and he made the observation that, okay, what fundamentally do drones do that's differentiated and provides a strategic and tactical advantage? They're cheap, they're fast. Like you can build them quickly, you can deploy them quickly, you can get them into action quickly. And he actually likened um, graph databases to this in the sense that the way government oftentimes and industry oftentimes tries to tackle these connected data problems is to use technologies that can maybe incidentally with strings and baling wire handle deeply connected data. Nothing wrong with relational databases. I spent most of my career working with them, but they just max out when you've got the need for flexibility and lots of data coming in, and it's a different shape data every other day. And when you've got these more complex causes and effects that occur in data that is shaped like networks or data that's shaped like hierarchies, which by the way is how much of the real and digital world shows up. And so the comment he made is, likening projects he'd seen throughout his career where it would take like 3 years and hundreds of millions of dollars to build this massive system. Is like, look,
Right.
the Neo4j based systems that we've built, like it's an order of magnitude or two cheaper, and
Right.
we can deploy it in a few months, and then we can deploy V2 in like another few months. And he likened that to like the tank versus drone one that you were saying earlier. So I think that's actually a pretty amazing analogy.
Yeah, and I'll throw it over to Jon to comment on that. What Philip just mentioned is such a huge story, and I'm hearing this from people. A good friend of mine is a developer, and his girlfriend just built a website in 2 days, including API connections. She has no knowledge of APIs. She built a website in 2 days that a whole team of people across overseas took 6 weeks to do incorrectly. And you're like, wait a minute, what's going on here? I mean, part of the challenge is just
Yeah.
knowing what's possible with these new technologies and knowing that it's possible and that you can do things in a much different way. I mean, that is a massive
Yeah.
transformation. What do you think?
Yeah, no, it is. And I'll give you an example. When we first tested out our system, we built a bunch of our things that are sort of patent pending at the moment. We did it on a Neo4j graph, and we were using LPGs or label property graph sort of elements to really sort of semantically enrich these environments in ways that were hyper tangible because you can allow yourself to really assign properties that can be attached directly to both the nodes and the relationships between these things on the edge. And ultimately, you can still contain multiple properties within that structure. So we thought about this from an engineering principle. I'm an engineer by background, petroleum engineer, worked in the oil industry forever, but my ability to do analytics started with my ability to sort of define, and we'll use terms, ontologies or the schemas within the structure of the data environment I was operating in. And what you can do within an LPG or a label property graph is you can start to seed that and semantically embed and sort of encode that environment in super tangible ways where you can start to define, you know, the temporal elements associated to any data environment, the geographic elements associated to it, the classifications associated to it, and then a intelligence construct being able to do this actually starts to enable your ability to move quickly through a data environment and define it to its security cleared encrypted portions of that environment that are relevant to the query that you're operating in, which is something that we're working with the government on. But at the end of the day, whether you're doing strategic asset management, forensic accounting, cybersecurity problems, that network basis, if you're looking at something that looks like a network, like graphs enable your ability to define and encode that network in ways that allow you to chop it up and interrogate it that are super, super tangible. And
Wow.
so, like, it is a fundamental part of what we're doing. And we picked Neo4j because they're on the leading edge of what they're doing as a partner. We were looking for people that sort of fit in the same space that we wanted to achieve great things in, and they tee up our ability to do so in such a super tangible way.
Yeah.
So we're definitely happy that GraphRag's here, and we're definitely happy to be partnered with Neo4j, because we are, I think, together going to be sort of changing the future outcomes for scaled implementation of generative AI.
I love it. And final thoughts from Philip Rathle of Neo4j. I'll just say that I think knowledge graphs are a fantastic conduit to this next generation of technologies because they can capture so much relevant information about entities and relationships and characteristics, really. And that can help make sense of what is otherwise tremendously unwieldy, unstructured data. Final thoughts from you, Philip. Go ahead.
Yeah, final thoughts are this has become much easier thanks to Gen AI technology. So it turns out that you can take unstructured data and you can rip it into a graph using LLMs. So we've got lots of free tools and open source and examples that folks can use. And it also turns out that many structured sources translate naturally into a graph: product hierarchy, supply chain, et cetera, people hierarchy. So for the systems you have that are in relational databases already, there's now an ISO standard. We talked about this the last time we spoke,
Right.
Eric, for literally transforming data from tables into a property graph. And there's lots of tooling and like including visual, like, click, reverse schema engineer, click again, model the graph, click again, bring the data in. So I guess my closing thought would be, if any of this sounds exciting, don't be too daunted as to how to get started. There's lots of new great methods that make it much easier to bootstrap.
Yeah. Bolt.new, by the way, that's what my friend's girlfriend used. She was using Bolt.new. Didn't know a thing about APIs, didn't know a thing about the HTML, web design, didn't know anything about that. Just banged it out in like 2 days and it works and it's great. You're just like, oh, what is going on? Basically, I predicted this at the end of last year. I said, folks, we are going to enter a phase of hyper accelerated innovation. And that's where we are right now, and you got to hop on the surfboard or the skateboard or something and just get rolling with this stuff because it is changing very rapidly. And the companies that do not embrace this stuff are probably going to have some trouble. But look these gentlemen up online: Philip Rathle, Neo4j, and Jon Brewton, Jon Brewton, Brewton, from data². We'll be talking to you next time. You've been listening to DM Radio.